This is a recording of 2.1 through 2.5. Unfortunately, I've already recorded it and the video did not process. So here is my recording, take 2. So here we go. We are going to review linear inequalities, and we want to make sure we have this down for our test. If you're looking at this review, you will notice the next page is the answer key for you. So as you're doing problems, you can check them. Obviously, you can check on this recording too. So here we go. We're going to start out by solving equations. I want to remind you that when you solve equations, you do not always get a solution. You might get no solutions or infinite solutions. So you would get no solutions if you go to solve it and the variables cancel out and you have an untrue statement like 10 equals 0. And you'd get infinite solutions if the variables cancel out and you get a true statement because it's balanced. Okay, also, we might not always get nice integers. You might have some fractions or decimals, so beware of those. We're going to start here by distributing this 6. That's really our best option, is to clean this up. I could divide by 6, but we're going to go ahead and distribute. So I have 42a plus 42 is equal to negative 30 plus 6a. And then I'm going to go ahead in one step and I'll move the a's to the left and the constants to the right. So I'm going to subtract 6a from both sides. At the same time, I'm going to move the 42 to the left. And so I get a positive 36 on the left times a, and it is equal to, over here, a negative 72. And then I'm going to do my last step, divide both sides by 36, and I get a equals negative 2. Now, in order to check this answer, because I'm taking a test, I'm getting ready to take one, so I want to practice taking that answer and plugging it in, and the left side should be the same as what I get out on the right side. So always good to check your answers. All right, over here, I'm going to go ahead. I could just divide everything by 3, but I'm going to go ahead and distribute. I think more of us would do that. So 24n minus 3 is equal to negative 24n plus 18. And honestly, I'm done. No solutions. It's never going to happen. And the reason there's no solution on this one is if you look, the negative 24n minus 3 will never balance with adding 18 to it. So I'm never going to have a balanced equation. So from right here, I can see there's no solution. I'm done. They have to be the exact same variable with different operations to them. Okay, if I didn't see that, again, I have a habit of moving the variables first, so I'd move this over here, and this would cancel out and leave me negative 3 is equal to 18, which is not true. And that's what tells me I got to show that that cancels. There's 0 n's over here, there's no n's over here, my constants are never going to equal. If I would have gotten 0 equals 21, same thing, no solution. All right, let's go ahead and go to some inequalities. We're going to add to this, we're going to do interval notation also. Interval notation. So we want to add that on to our answers. So looking at this, I'm going to go ahead and distribute. I couldn't divide by 3 and get nice numbers. So best to distribute here. So I get 21x plus 24 is greater than or equal to negative 28 plus 8x. Now you might take more than one step to do this next part, but I'm going to go ahead and I'm going to move the x over to the left, and I'm going to move the constant over to the right. So on the left, I have 21 minus 8x, which is 13x, which is greater than or equal to, and on the right hand side, I'm going to add these up and I get a negative 52. Now I'm dividing by 13, so I do not flip my inequality. So that's going to cancel. I keep the greater than or equal to, and negative 52 divided by 13 is negative 4. Now that is my answer as an inequality. So let's go ahead and look at the number line. It'd be a closed circle on negative 4. And x is greater than or equal to, we would be shading going this way. There it is. Now let's take a minute and let's put that into interval notation. Interval notation always goes from the low to the high. And the low here is negative 4, and it is included, so bracket. And it goes to positive infinity, always a parenthesis. So that is our final answer. All right, we've got another one where I want to go ahead and distribute that -2. So that gives me a -14 plus 6b is greater than or equal to b plus 6. I'm going to go ahead and bring the b to the left and at the same time add 14 to the right. I keep saying it, you don't have to do this all in one step. So I get 5b is greater than or equal to 20. Divide both sides by 5. Again, I only flip the inequality if I multiply or divide by a negative. So I'm going to keep what I have, put that on the number line. It is a closed circle again, and b is greater than, so we are again going to the right. So that's what I have. There we go. And in interval notation, it starts and includes the 4, and it goes to positive infinity. All right, these next two problems come from section 2.2. So I'm going to go ahead and work through these. And it would be x minus 2 over 5. That's really what we want it to look like, a fraction equal to fraction. In this program, we couldn't get that typed like that. So that's what I have. Anytime I have a fraction equal to fraction, I can solve them by doing a proportion. And so I'm going to now cross multiply. So I can solve proportions. So as long as I have an equal sign, it's going to be x minus 2 times 17. And notice I'm going to put this in parentheses. It's not just 17x, it's 17 times x and -2. And then I have my 5 times 10. So I get 17x minus 34 is equal to 50. And then I'm going to add that 34 over, and I get 17x equals 84. Divide both sides by 17, and I get x is approximately 4.94. X is approximately 4.94, and that came from 84 over 17. Okay, we have a word problem here, and so when we are talking about this, we want to look at what's important. It says 30% of John Adams, okay, so 30% do not eat lunch. 180 total students do not eat lunch. So that 30% is 180 of the kids in school. How many total kids are there at John Adams? So when we do these proportions, we're using the idea that it's the is over of. Oh, or the part, sorry about that, or the part over the whole. So is over of, is the part. It is this many students out of this whole. So is over of equals always percent is out of 100. So I know that I have 30% of 100% at the school that don't eat breakfast. And that's 180. So the don't eat breakfast over everyone, the don't eat breakfast over everyone, which is x. Now, you can go ahead and cross multiply, but I see that I can divide out the 10 there. And so I'm going to multiply. I have 3x equals 1,800, and I divide by 3, and I end up with 600 students. Total 600 students at John Adams. And out of those 600, 180 don't eat breakfast. Okay. Let's jump back into here. We're using x and y intercepts. We want to make sure that we do these as ordered pairs. So let's give you a reminder there. Always have to answer as ordered pairs. And notice one is an equation and one is an inequality. All right, so looking at this, I want to solve using x and y intercepts. So the two facts we know about our x-intercepts is that it is on the x-axis, which means the y value is 0. So there's my ordered pair. Take your 0 and plug it in. That's going to wipe out the y. So 2x equals 1. X is 1/2. So here I put my point at 1/2 0. Then I'm going to find my y-intercept, and I know that my y-intercept is on the y-axis, and since it's there, the x value is 0. We're looking for y. So come back up. 2 times 0 is 0. We're left with y equals 1. And that's my other point. And we're going to go ahead and draw in our line. So the points are a little bit close together, so I'm going to try to do the best I can to get an accurate line here. There we go. So graphing using x and y intercepts. Now when I go to do an inequality, I'm going to follow all the same rules. I'm going to find my x-intercept by using my ordered pairs. Take the 0, it's on the x-axis. That's going to wipe that out. Negative 5 times 0 is 0. So I'm left with 4x is greater than negative 10. Okay, divide by 4. So I keep my inequality. I'm going to reduce that to negative 5 halves, or negative 2.5. So when I go to graph this, I put a point at negative 2.5 on the x-axis. Now I'm going to have to shade. So if you can just take a minute and look at this, don't see this as a vertical line. This is what x is when y is 0. I would have to shade greater than negative 2.5. So that means I would be shading to the right of negative 2.5. All right, to find the y-intercept, I know the x value is 0. So I'm going to take my 0 and plug it in. That's going to wipe out the 4x, and I'm left with negative 5y is greater than negative 10. So when I divide by negative, don't forget to flip your sign, and I get a positive 2. So then I put this point here at 0, 2, and y is less than 2 should be shading going down. So when I go to do this, I want to make sure that I look for a dashed or solid. In this case, I want a dashed line because it's not equal to. I want to extend that line through my graph, and I want to make sure that I make it look dashed. If I forget, I guess I can always write the word. And then if you look, by looking at the individual x and y, both of them shade in this half. So this is the half of the graph that I'm going to shade. There you go. If you don't like shading using your x and y intercept values, then you can use a test point. So that's the other option to shade. And the test point I like to use is 0, 0. And if I put 0 in here and 0 in here, then 0 is greater than negative 10. That is true, so that point works, and so does everything else. If it's not true, then I shade the other side. Okay, let's keep moving here. So looking at number 9 and 10, they're telling me to put them in slope-intercept form. So I need to solve both of these for y equals mx plus b. All right, so here we go. I'm going to subtract the x from both sides, and I get 2y equals negative x minus 6. Divide both sides, or sorry, divide everything by 2, and I get y equals negative 1/2 x minus 3. So this is going to give me points on my test. I'm looking for the y equals in slope-intercept form, and then we're going to graph it. So let me pull. My slope is always paired with x. My y-intercept stands alone. So I'm going to plot that y-intercept at 0, negative 3, and I'm going to go down 1 and right 2. Down 1, right 2. You want to reverse it. You can go positive, but you have to do a negative 2. So sketch in your line. Find something to help you make a straight line here. There you go. Now let's go to our inequality. I'm going to again solve for y by subtracting 3x from both sides. So I have negative 2y is less than or equal to negative 3x minus 2. Divide each piece by negative 2. I don't like to have that big fraction. I want to show it so I don't lose it. And so I get y is greater than or equal to 3/2 x plus 1. All right, so that is my y equals mx plus b. That's going to give me credit for showing that. And then if you want to pull, your slope is 3/2, and your y-intercept is 1. So I start on the y-axis. Make sure you're finding the right axis. And then I'm going to rise 1, 2, 3, run 2. If you want to go negative 3 over negative 2, that also gives you a positive. So down 3, left 2. And it's a solid line because it's equal to. So I'll draw in my solid line. And then you need to determine where to shade. So looking at my inequality, because it's solved for y, I can't go back up here. Because it's y is greater than the line, if you look, my graph is cutting through here, and y gets greater as I go up the y-axis. So I'm using the y-axis as a number line. So I'm going to go ahead and shade this upper half of my graph. Again, if I did a test point of 0, 0, I can go back to the original, or I can do it in here. That'd be 0 minus 0. Is 0 less than or equal to negative 2? No. And since 0, 0 doesn't work, that means nothing on that side of the graph works. So it has to be the other half. Okay, now we're going to get into writing equations of lines. So we want to write the slope-intercept form of the equation through two given points. So the first thing I have to do is I have to solve for m. So it doesn't matter whether you do point slope or slope intercept. I want my final answer to be y equals mx plus b, and I have to find the slope. So I'm going to go ahead and find the slope over here, which would be y minus y. So y minus y over x minus x. Watch your negative signs there. So I get negative 6 over 3. So I have a slope of negative 2. So that's my slope, and I'm going to use my slope. And if you really take a minute and look at this, this is the y-intercept. The y-intercept is 0, negative 3. So my line's done. Y equals my slope, negative 2x minus 3. There is the equation of my line. Now, let's say I didn't see that and I didn't catch that 0, negative 3 was there. Or it's like this and I don't have a y-intercept. I'm going to use my slope of negative 2 and this x and y, and I'm going to plug it into slope-intercept form. So y equals mx plus b. So here we go. Y, in this case, is 3. M is negative 2. X is negative 3. And then plus b. 3 equals 6 plus b. Subtract 6. And I get b equals negative 3. So if I have my slope of negative 2 and my y-intercept negative 3, we've got the same equation. All right, let's come over here. We're again going to solve for m first. So it's negative 2 minus 0. And then it's 5 minus a negative 5. So I end up with a negative 2 over 10. So I have a slope of negative 1/5. So using that slope in one of the ordered pairs, it doesn't matter which one you use. I'm going to go ahead and use this one as x and y. You could use y equals mx plus b again, or you could use point slope. So I'm going to go ahead and show point slope just so you have one of each example. So you have to know your point slope formula and you have to watch your negatives. So this would be y minus 0 is equal to our slope of negative 1/5 times x minus negative 5. So catch that minus and negative changing. So I end up with y equals negative 1/5 x, and the negative 1/5 of 5 is negative 1. And there is the equation of that line. All right, given a graph, find the line of the equation. So the two things I need to write the equation are m and b. And so in this graph, I have a nice y-intercept at negative 5. And I can find another point, and I have to make sure it's a good point that crosses in the crosshairs here, and I can find my slope. Now my line's dropping, so yes, I'm going to go up 2, but I'm going to go left 3. And so the equation of my line is y equals negative 2/3 x minus 5. So being that I can find the information on the graph, that's all I need to do. If I couldn't count out the slope easily, or the y-intercept wasn't showing, or it wasn't a nice integer, then I would pull 2 points off the graph and I would solve for my equation using the same method. All right, the bottom half is essentially the same thing we did on 11 through 13. I need m and I need b. When I go to do these, I need to know the rules. So parallel lines never intersect and they have the same slope. And once I know that, if I tell you I want something parallel to this line, this is already solved for y, so the slope of this line is negative 5/2. So the slope of any line parallel to it is also negative 5/2. So using my parallel slope, which is the same, and my ordered pair x, y, I can write the equation of this line. I'm going to go ahead and do this one in slope-intercept form. So it would be y is 2 is equal to my negative 5/2 times x, which is negative 2, plus b. I'm solving for b. Here we go. 2 equals, these cancel, the negatives cancel, so 2 equals 5 plus b. b equals -3. So using my y-intercept and my slope, the equation is y equals -5/2 x minus 3. And let me remind you that this ordered pair -2, 2 is not a point on this line. This is the line I want it to be parallel to, and this is an anchor point. All right, we have another one that's parallel. The problem is I don't know the slope. So I have an extra step where I have to solve for y equals mx plus b. Divide each piece by 4. And so I get y equals a positive 1/4 x plus 3. Okay, all I want from this is the slope of 1/4. After that, I'm really done with that. I want to talk about my line being parallel, having the same slope of 1/4. And then here's my x and my y. So I'll go ahead and I'll do this one in point slope form, just in case you like that. And so that would be y minus a -2 is equal to our slope of 1/4 times x minus x, which is 4. So I get y plus 2 is equal to 1/4 x minus 1. I'm just distributing. Subtract the 2, and I get y equals 1/4 x minus 3. And that is my answer. Okay, now the next two, got to pay attention, ask you for perpendicular. So we know that perpendicular lines are opposite reciprocal slopes. Opposite reciprocal slopes. So opposite means change of sign, positive, negative. Reciprocals take the inverse of the fraction. So given this first one, my slope is already showing that it's -1. And so the perpendicular slope would be the opposite, so positive 1. 1/1 is reciprocal of 1/1. And here's my ordered pair, x and y. So I'll go ahead and put this into y equals mx plus b. So if it helps you write your template, y is 3, and that equals my slope times x plus b. And, like that there, I get 3 equals -2 plus b, add 2 to the other side, and I get a positive 5. So my equation, using my perpendicular slope and my y-intercept, you don't want to come back. I don't want a parallel line, I want a perpendicular line. Would be y equals 1x, or x plus 5. There we go. All right, we have one more, same idea, we're doing the same thing. I've got to find the slope based on the relationship given, and then I'm going to plug in my anchor point and write my equation. Before I can find my perpendicular slope, I need to find the slope of the original line. So I'm going to go ahead and subtract that -2x. I'm going to divide each piece by -9. And that's going to cancel. I get y equals 2/9 x minus 5. Now I know when I get something like that, I always double check, oh, why didn't that work nicely? It is, it's 2/9. So my slope is 2/9. Now I'm going to put this little line here. That's it. I'm sectioning that off. I'm done with it. I'm going to use my perpendicular slope, which would be the opposite reciprocal. So -9/2. I'm going to use my x and y and build my line. This time I'm going to go ahead and do point slope. So it's going to be y minus the y value equals -9/2 times x minus the x value. So catch that extra negative there. That's the downfall of point slope, is that negative sign. So I get a -9/2 x, and then that's going to cancel out and give me a -18. And I add 5, and I get y equals -9/2 x minus 13. And that is my final equation. And again, I don't want to go back to 2/9. I wanted that to get the opposite reciprocal. All right, keep practicing these. Make sure you know your rules. Make sure you look for details, whether it's an inequality and you need to shade, dash, and solid, or equation of a line, as well as details like using slope-intercept form or x and y intercepts. You also have to consider that you might have special cases when you're solving equations, and take the time to take that and put it back in. I can also take answers here, x is greater than or equal to -4. I could take options like 0 and plug in and see if it's true, to see if I have that right answer. If I plug in -4, these should be equal to each other. If I plug in anything greater than -4, this side should be greater than the right side. If I plug in something over here, I should get a false statement.